Hello, myself Sandeep DK from NMMIT. My topic is semiconductor devices. Semiconductor is a material which electrical conductivity value is falling between conductors and insulators. Conductors are mainly copper, aluminium, etc. and insulators are mainly wood, glass, rubber, etc. Semiconductor can be compounds such as gallium arsenide, pure silicon, and silicon is used in electrical circuit fabrication, and gallium arsenide is used in solar cells and laser diodes. In semiconductor, the mobility of electron is higher than that of the holes. Types of semiconductors are intrinsic semiconductor and extrinsic semiconductors. Intrinsic semiconductor is a pure form of silicon, gallium arsenide, and in extrinsic semiconductor there are two types: N-type semiconductor and P-type semiconductor. Semiconductors are used in almost all electronics devices. Their reliability, compactness, and controlled conductivity of electricity make them ideal to be used. And the semiconductor devices are transistors, diodes, photosensors, and microcontrollers, etc. In this section, we learn about semiconductor diode and p-n junction diode biasing. The diode is a two-terminal device made up of fusing the p and n semiconductors. The figure shows the p-n junction diode and symbol of the p-n junction diode. The p-n junction diode consists metallic contact and p and n semiconductor. p-n junction diode biasing: when positive terminal of the battery is applied to the p side and negative terminal of the battery is applied to the n side, the width of the depletion layer is reduces when positive voltage is applied to the p side. That allows the flow of current in the forward direction. In reverse biasing, the negative side of the negative terminal of the battery is connected to the p side, and positive terminal of the battery is connected to the n side. In this biasing, the depletion region width increases, and that blocks the flow of current. The application of the diode is rectification, LEDs, and solar cells, etc. The figure shows the VI characteristic of the p-n junction diode. The VI characteristic is the curve between voltage and current through the circuit. The x-axis indicates the voltage and y-axis indicates the current in the p-n junction diode. With the help of the curve, we can understand that there are three regions which diode works. There are zero bias, forward bias, and reverse bias. When the p-n junction diode is in zero bias condition, there is no external voltage applied, and this means that the potential barrier at junction diode not allow the flow of current. When the p-n junction diode is forward bias condition, p-type is connected to the positive terminal, while the n-type is connected to the negative terminal of the external voltage. When the diode is arranged in this manner, there is a reduction in the potential barrier. For silicon diodes, when the voltage is 0.7 volt, and for germanium diodes, when the voltage is 0.3 volt, potential barrier is decreases, and there is a flow of current. When the diode is in forward bias, the current increases slowly, and the curve obtained is non-linear as the voltage is applied to the diode overcome the potential barrier. Once the diode overcomes the potential barrier, the diode behaves normally and the curve rises sharply as the external voltage increases, and the curve obtained is linear. When the p-n junction diode is in negative bias condition, P-type is connected to the negative terminal while the N-type is connected to the positive terminal of the external voltage. This results in increases in the potential barrier. Reverse saturation current flows in the beginning as minority carriers as present in the junction. When the applied voltage increases, the minority charges will have increased kinetic energy, which affects the majority charges. This is the stage when the diode breaks down. This may also destroy the diode. Till now we have studied about semiconductor diode, their structure and characteristics. Now we are going to study transistors and their characteristics and structure. Transistor is a type of semiconductor device that can be used to conduct and insulate electric current or voltage. A transistor basically acts as a switch and an amplifier. In simple words, we can say that transistor is a semiconductor device that is used to control or regulate the flow of electronic signal. Transistors are one of the key components in most of the electronic devices. Transistor is a basic building blocks of the electronics devices. Transistor is developed in the year of 1947 by American physicists. The transistor is considered one of the most important invention in the history of science. The transistor consists of mainly emitter, base, and collector. Base is energizes the transistor, and emitter and collectors are the positive and negative terminals. PNP, the two P type semiconductor is used with N type semiconductors. Till now we have studied about transistor structure. Now onwards we studying about VI characteristics and types of transistor configuration there and types of transistor. In transistor there are several types. BJT. BJT is a bipolar junction transistor. In BJT there are two types, PNP transistor and NPN transistor. Then FET. FET is a field effect transistor. And MOSFET. MOSFET is a metal oxide semiconductor field effect transistor. And IGBT. IGBT is a insulated gate bipolar transistor. In physics, the graph representing the relationship between the current and voltage of any transistor of any configuration is called transistor characteristic. In this section, let us learn the transistor characteristic in detail. Characteristics of transistor. Any two-port network which is analogous to transistor configuration circuit can be analyzed using three types of characteristic curves. They are input characteristics, output characteristics, and current transfer characteristics. Input characteristics. This shows the input characteristics, and this graph shows the output characteristics. Input characteristics, the curve describes the changes in the values of input current with respect to the value of input voltage, keeping the output voltage is constant. There is output voltage keeps constant and varies the input voltage and current. In output characteristics, the curve is obtained by plotting the output current against voltage, keeping the input voltage current constant. Current transfer characteristics. This characteristic curve describes the variation of output current in accordance with the input current, keeping the output voltage constant. Configuration of transistor. Any transistor circuit can be designed using three types of configuration. Three configuration of the transistor are based on the connection of the transistor terminal. The three types of transistor circuit configuration are common emitter transistor, common base transistor, and common collector transistor. Each of these three circuit configuration has its own characteristic curves. Based on the requirement, the type will be chosen for this circuit. I explained what I know about semiconductor devices. I hope this video will help. Thank you.